Good afternoon, everyone. Sachin Kulkarni here. Let's wait for a minute for everyone to join and we'll start. Thank you. Welcome, everyone. This is Sachin Kulkarni here. Good afternoon. We're going to start with our webinar today, which is rapid infrastructure provisioning, of course, through deployment automation. If you have any questions during the webinar, please park those questions. We will look at those questions at the end of the session. I'm planning to run this webinar for close to 35 to 40 minutes, and if there are any questions or if there's any discussion, we'll have time for that as well. So let's start with the agenda first. So what we are going to cover today is setting up the infrastructure for testing, and this is particularly for the computing systems, storage, networking, cloud computing domain. Okay, so mostly from the systems domain perspective. Infrastructure deployment automation is the key today. We will talk about that. What is the approach? The approach would be the infrastructure as a code approach. Okay, and then we'll look at the tools which are common, and we'll cover two of the tools today, which are Vagrant and Terraform. Okay. Now, let's talk about setting up the infrastructure for testing. So the most important aspect of the testing, right, it typically starts with the planning. And as part of the planning, you must consider the aspect of setting up the test bed and test environments, right? So what exactly is the test bed or a test environment? It typically setting up the software and hardware that is required for the product under test, right? It should provide an environment for testing team or the QA team to execute their test cases for any application, software, or product under test. It typically comprises of the typical hardware, software, and networking components. Okay, but as we see, it is the most important aspect because it sets up the bed for the experiments, for the testing, for the quality analysis, and of course paves the way for success of the product. Correct. Typical challenges, while setting up the infrastructure testing, start with the usage planning, right? How much infrastructure we need for a particular test execution? What would be the usage of that? right? And that usage is directly linked to the cost factor, which is of course the factor for any software test bed and test environment setup, right? Another important aspect is how do we share, this infrastructure within team, across teams, across the globe now. Because of the current situation, it is imperative that the test environment is accessible anywhere in the world. Now, depending on the product or the application or the software under test, what is the complexity of that particular setup? How much time it is required, to bring up the setup? And of course, as we mentioned, remote environments. Now, when we talk about the setup time, the cost, the complexity, what is the right approach? Should we deploy the product on the given hardware and software every time that we test, or should we maintain the test bed for long running? Those are the answers we need to find when we start planning for test bed and test environments. Now, what are the options that we have, right? The most important or the major factors that we should consider when we decide the infrastructure for testing are cost. Of course, it starts with the cost, the physical footprint that we want. So where exactly we want, whether it's needed to have the physical environment or you can live with virtual environment, what exactly we need, the lifespan, how long do you need that particular infrastructure, right? Migration, that's another important aspect. If you want to move or migrate your infrastructure, is it feasible? It is required, right? Performance and efficiency, which are the two vital elements, of course, when we use your infrastructure, right? And of course, the disaster recovery and high availability aspect of it. Now let's look at few of the options. What exactly we want to consider our infrastructure for, right? Be it physical or versus virtual. Physical hardware has its own advantage when it comes to a simple solution or when performance is paramount, correct? Now, performance at the cost is what physical hardware offers, right? But with the evolution of the technology, it becomes difficult for physical hardware to maintain for a longer period of time with more cost involved. It needs a physical space. It takes a lot of other things into consideration. And as we have seen the evolution, we're moving more towards the virtualization. Now, virtualization is nothing but using a hypervisor, which sits on top of your bare metal, or it could sit on top of your operating system and provide you all the elements that a typical physical hardware can actually provide, including the virtual hardware, the virtual machines on top of it, including the operating system, applications, packages, everything as is. The advantage, of course, you can be more effective in using your infrastructure. It's easy to migrate, easy to maintain, and of course, more efficiency. Maybe a bit of performance overhead, but of course, it can be compensated with the other advantages that virtualization provides. Now, when we talk about virtual servers, another important factor comes into mind is cloud. What is virtual versus cloud? Cloud is another form of virtualization. When we see the differences, the factors impacting the decision for virtual service versus cloud servers, right? Virtual servers, of course, we have more control over that. We can decide some of the important configuration and parameters, change it whenever we want it, right? Be it power consumption or be it the other configuration. So it provides a way to do the customization, and of course, we can choose the hypervisor that we find more suitable for our need and earn a bit of cost effectiveness. But when it comes to cloud servers, it provides the standard benefits of scalability because it gives you an option to scale up or scale down and pay as you go option. But of course, the cost is a bit higher as compared to a regular virtual server. It allows you to expand your capacity, so there's no limit on the capacity that you need. Of course, it provides you the high availability aspect of it. Okay. Now with the evolution of containerization, right? What is the difference between virtual machines and containers, right? Again, a typical infrastructure, as you see here, we can put a hypervisor on top of it and then use that hypervisor to provision virtual machines on top, right? But in case of containerization, it is slightly different. In case of containerization, we can get more out of the same hardware by using a container engine. And instead of a complete virtual machine comprising of operating system, binaries, libraries, other packages, and of course the application of the software under test deployed on top of it. Instead of that, we can use a container, which is a lightweight component and has only the runtime environment, including the binaries or libraries that you need, and of course the the application on top of it. Both has its own advantages and disadvantages, and we need to look at all these aspects when we consider infrastructure for testing, right? The cost, lifespan, migration, efficiency, performance, high availability, and of course, your disaster recovery. These are the few important aspects for setting up infrastructure for testing. Now let's look at what exactly is the automation when it comes to infrastructure deployment. Okay, uh, a simple automation process is nothing but writing scripts, okay, to build up the infrastructure or the environment that we need. It starts right from installing an operating system to install and configure your instances or your virtual machines, or even the configuration of those virtual machines or instances, and setting up the networking on top of it, and how basically the software communicates with each other, right? Why automation? Because it allows greater consistency. It reduces human error, right? And of course, when the task is repetitive, it takes that repeatability away and allows you to do it at the click of a button. When you script or when you automate these environments, right, it is easy to apply the same setting, same configuration to either few nodes, a single node, few container, or even 1,000 containers or 1,000 virtual machines, right? So it is easy to scale when you automate. Of course, it reduces time if you want to deploy a very large number of servers, right? And it's easy to create an exact copy of the environments, and it is vital, as you know, to create test environments which are to as close as possible to the production environment, right? Again, it brings agility to both your development and operations, and that's why the infrastructure deployment automation is the buzzword today. Now let's look at the approach. How can we achieve that? And one of the approaches is using infrastructure as a code. It is one of the evolving approach. By definition, infrastructure as a code is the process, of managing and provisioning the data centers through machine-readable definition files. Typically, it is in the YAML format, right? And rather than having physical hardware configuration or interactive configuration tool. So all your configuration environment is written in files, right? And as you know, if it is easy to bring up the same configuration every time we deploy it and even manage it on the go, that is the approach that we think as, when we think infrastructure as a code approach, right? There are a lot of benefits, of course. The most important is the efficiency and consistency, because every time you bring up your entire infrastructure, right, you can always define the infrastructure model using those files, and every time it will bring up the same environment for you, right? So that could be a very cost effective, that is quite fast, and of course it is simple and secure as well. Now let's look at few of the tools, which can help us for the infrastructure deployment automation, and of course infrastructure as a code tools. So infrastructure as a code tool, few of the important tools are Terraform, Ansible, Chef, and Puppet. As we have seen for last some time, Terraform and Ansible have really gone way ahead of other tools, right? What is the difference between these two? So Terraform and Ansible both are basically infrastructure as a code tool, but Terraform is of course open source, right? So anyone can use Terraform, and on the other hand, Ansible is on Red Hat. Now both of these are procedural configuration, right? Now where Terraform is completely declarative approach, and Ansible is procedural and declarative approach. Now the difference in those two is that when we consider Ansible, we need to write the procedure step by step, and it follows the same thing. So when you write any Ansible code, it is basically more work, but of course it gives you better control. As compared to that, Terraform is simple. It provides you the declarative way of defining your infrastructure. Okay, and it also maintains the state. Okay, now let's look at the tools for continuous integration and deployment. Of course, Jenkins is quite popular in that segment. Vagrant is one of the tools that we will take a look at how it can be used to rapidly deploy infrastructure. And Docker is, of course, the containerization platform. Now, you must be wondering, where is Kubernetes, right? So Kubernetes is, of course, the Docker management or the container management system, right? And I think Kubernetes in itself could be a topic for another webinar. So we will restrict our webinar to the tools that we have just mentioned, which is in the Terraform and, of course, Vagrant. Now let's look at Vagrant. How can Vagrant help you to build your test infrastructure rapidly? So it's a very efficient tool to configure virtual machines. It could be for development or test environment. It may not be that suitable for production environment. Okay, but as we are talking about QA testing development, we can use Vagrant there. It is based on a simple configuration file, which is called a Vagrant file, which is the crux of this tool. It consists of the complete set of configuration that you need for any virtual machine, including everything, the capacity, the resources that you need, the cloud init configuration, the networking that you need, packages that you want on top of the virtual machine. Okay. Vagrant is, it's very specific tool for quick and rapid creation of environments. Okay, and of course it is quite efficient in number of resources that you need using very small number of virtual machines. Okay, as we discussed, it reduces setup time, it increases equality among developers, means that it can give you the exact same setup for a very short span of time at a very easy way to deploy. Okay, it's very easy to create a very portable work environment, of course, and it can use any hypervisor like VirtualBox or KVM underneath. Now let's look at the use case that we have for AFour. Okay, what we have used Vagrant for is deployment of a very complex OpenStack environment. Okay, as you know, OpenStack itself is a complex environment. Now, how did we achieve that? We use the ready-to-use Vagrant files, and these Vagrant files are even embedded in the complete CI/CD pipeline that we built and achieve end-to-end test execution. We use KVM hypervisor for this, and It uses the Cola Ansible way of deployment of OpenStack on CentOS. So we will show a demo shortly in the next slide. And it also supports the Cola Ansible deployment on Ubuntu and of course OpenStack Ansible deployment on CentOS. A typical time for deployment of these complex, OpenStack environment could take probably few hours. But using Vagrant, it is reduced to 30 to 40 minutes. And within those 30 to 40 minutes, it will give you exactly same OpenStack configuration. As you look at the data flow here, I have just mentioned either you can use the Vagrant file directly as a user or you can use check-ins for your utilization. And then it goes to Vagrant, which uses the KVM hypervisor to deploy the OpenStack. And then it can be utilized for deploying instances on top of it. So Vagrant here is used to deploy OpenStack itself. Let's have a look at the demo. I'll play the video and explain what it's doing. So what we have in front of you is a simple Vagrant file, and this Vagrant file basically, explains, as I mentioned, the configuration for your OpenStack environment. So as we have seen, the compute provider is Libvirt, which is your KVM. It provides the configuration. And this is a typical 2-node OpenStack deployment of a compute node on a one VM and controller on another VM. As you can see, the network information as well over there. Okay. So this is so the first highlighted area is your configuration of the VM and for the compute, and second one is the controller. Okay, as you see here, we can clearly specify the memory requirement, how many CPUs it needs, what type of storage it uses, what type of devices you can attach. Okay, and of course the information as to what would be the host name and what are the different networks that you need on top of it. Okay, it also provides, of course, the other parameters like username, password, and other details. Okay, now let's look at how exactly it deploys it. Okay, a simple command, Vagrant up, which will run in the existing directory and use the available Vagrant file to deploy this complex infrastructure. So as you see on your screen, it has started a deployment, and this is going to take us around 35 to 40 minutes. Okay, so we are not going to play everything out here. So we will cut short the chase and jump towards the end of the demo. Okay, so we will move towards the end of this execution, and we will see how it looks towards the end. Okay, it will show a lot of information on your screen, of course, and towards the end it will complete the execution and show you that your infrastructure is ready. Okay, as you see your screen, all the tasks that are performed by Vagrant are clearly listed out over here. Okay, a complex environment, like OpenStack or your container-based environment, or any other system under test, a NAS filer for that matter, you can utilize Vagrant for the deployment. And of course, as we have seen before, it is quite effective when we consider this particular deployment for development or testing purpose. And it can be utilized to greatly reduce your time utilization for setting up the infrastructure. So Vagrant is one of the tools that can help you to deploy your infrastructure in a very rapid manner. Okay, so this can achieve you actually, great saving in terms of time and efficiency. And as you see, it is very time effective. As we have seen in this use case, it is quite useful to integrate your Vagrant deployment, as it is an infrastructure as a code approach and can utilize this particular way to, deploy a new hardware. Okay. So as you see on your screen, the vagrant up command is still going on, and typically it takes around this particular complex environment, it takes around 35 to 40 minutes to complete. So now as you see on your screen, it is almost complete, and your OpenStack environment would be up and running shortly. Okay. So there it is. Second up command is successful. Now we will look at how exactly the OpenStack looks from the UI part. Okay, so this is a two-node configuration. We have one compute node and one controller, and we will use the same credential as we use while configuring this environment. Okay. So once you go to the OpenStack dashboard, we need to specify the credentials, including domain, username, and password. Okay. And of course, it will bring up the OpenStack environment in front of you. So right over here. Okay. So this is the way we can use Vagrant to deploy a complex environment. Now let's look at another important file which is used within Vagrant file. So what exactly does Vagrant file do other than the configuration, right? So there is a specific script which is called cola-ansible.sh, which is nothing but a deployment script provided from OpenStack to deploy full Ansible based environment. Okay, so this is the version that we have used here, and the backend file simply execute this particular script to deploy your OpenStack environment. So this is the reference where you can see it takes the information from OpenStack documentation itself to deploy your Kula Ansible based OpenStack environment. Okay, so docs.openstack.org is where you can see all the information that you need for deployment. And of course, as we have demonstrated, you can use Vagrant to integrate the same to bring up your complex infrastructure up in few minutes. So that brings us to the end of this particular demo. Okay, now let's look at the next part. Terraform, right? As we just discussed, why Terraform, right? It's an open source infrastructure as a code tool, and it was developed by HashiCorp, as you probably know by now. It is a declarative form of language, or a coding tool. It allows you to use a high-level configuration language, which is called HashiCorp Configuration Language, HCL, to provide the desired or end state for cloud or on-premise infrastructure for running any application. It starts with a plan, how to reach that end state, and executes the plan by provisioning the infrastructure. And it also maintains the end state as is, even if we bring any change. It maintains the versions of the infrastructure as we make changes doing it. Now, since it is a very simple syntax, right? It allows you to use any number of cloud or on-premise data structure, right? It is safe and efficient in provisioning infrastructure, and it is responsive to any configuration change that we make. Okay, and it is one of the most popular tool that is available for infrastructure provisioning and automation. Okay, as we know, it is open source, it is platform agnostic, it can work on any service provider or any cloud provider, which we'll of course take a look at in the demo. And of course, it provides you the immutable infrastructure, right? What is immutable? Let me just quickly give you a brief on that, those who may not know this. So Mutable infrastructure versus immutable. So what happens typically that when you have the mutable infrastructure, which means that your physical server or your virtual machine is deployed and it is designed to take changes in. That means you can deploy new packages, new versions, new application, and keep running the same system all the way. But over the period of time, it develops a drift from the end state. Why? Because of the changes in the versions and other changes that we bring in. In case of immutable infrastructure, it is not designed to change. However, it allows you to maintain the two different versions when we bring any change in the configuration. Now, how beneficial that could be? It, it is because it is easy to move from one version of the infrastructure deployment to another as and when we need it. But it also allows you to go back to the older version, and Terraform precisely does that. Okay, so even though it is an immutable infrastructure, which means it doesn't allow you to change the given infrastructure, it provisions that by maintaining the versions of it. So as you go along and keep changing the configuration, it maintains those versions and it allows you to move back and forth within those states or versions of the infrastructure. Okay, let's look at the demo quickly. So this is a framework that we have developed in-house at A4 Tech. And as you see, it is a platform agnostic tool, right? But for the demo, we have used OpenStack here. It supports other cloud platforms as well, like AWS, Azure, and it supports deployment of any Linux or Windows instances on top of OpenStack. As you see, the right-hand side is the architecture or the flow diagram. It can be integrated with Jenkins, but right now we will demonstrate how a user can interact either directly or through sysadmin using the definition of the Terraform script, which go into the Terraform and deploy the infrastructure on top of OpenStack. So using Vagrant, we deployed OpenStack, which is Cola Ansible based. Now using Terraform, we will deploy instances on top of that OpenStack. Okay, so this is provisioning VMs instances on top of your platform provider. Okay, so let's start with the demo. What we have here is simple CLI based tool that is developed at AFour. Okay, and this tool is basically based on Terraform using modules. Okay, so what we have here is, as you see, there are three main directories which are modules that you can see on your screen. Okay, and at the top level, you will see a main Terraform file. Okay, which is your standard Terraform definition of what is the provider that we are going to use. It uses OpenStack right here. And as you can see, there are three modules that we have defined: creating instances from image, creating instances from volume, which is a volume booted image, a volume booted instance, and of course, a volume booted instance with multiple data volumes attached, Cinder volumes attached to it. So these are the three modules that are defined here. And as you see, it is quite modular. By adding new modules and set of directories, it can be scaled up further. As you see, there are different variables defined for each of those modules, and we will see where exactly those variables are utilized. Towards the end, we see the output of these modules, okay, which means that these modules will provide you a certain output once the deployment is complete. And here the output is the IP address that is assigned to each of those instances. Okay, now let's quickly look at the the variables. That means the parameters that are used for this particular models. Okay, So we will look at the variables at the top level, which is the parent variable set for all the modules that are used. It typically uses variables like image, what type of image we can use, and we can also define the default values, which can be overridden at any point of time. And of course, the instance name, volume size, the list of volumes, and other required information for deployment of typical, instances on top of it. Okay. Now let's quickly look at the uh, the files that are there inside each directory. Okay. Uh, for example, instance from image. So this is the main deployment file. Okay, and you can clearly see how many number of instances you can use. You can deploy one instance or multiple instance. You can specify the name for that and all the other required information such as image, availability zone, network, security group, and of course the user data, the cloud init configuration that you want to add. It allows you to provision your VM at the start using cloud init. Okay, and of course it provides output, which is your instance IP once the deployment is complete. Okay, quickly look at the variables within the same module to see how exactly the variables are utilized for this particular module. So this set of variables are applicable only for this module. Okay, and subsequently we will see how these volumes, these variables are changed based on the modules that we have defined. Okay, the next one would be the instance from volume, which is your instance booted from a volume. Okay, and we'll look at a deployment script. Now, if you want to see the difference between the first and this one, that we are deriving the image here, plus the block device is defined in this case, as this sender volume would be used for deploying this instance on top of OpenStack. Okay, so as you see, all the information required for the block device has been defined over here. Okay, user data is also provided, and the IP is the output in this case as well. Now quickly look at the last module, which is your volume booted plus multiple volumes attached, and the difference, sorry, so we are going over the variables again, and the only difference here is the volume size, and that is used for volume booted. And the last one is of course the multiple volumes attached to the volume booted instance. So the deployment is similar with the addition of dynamic block device at the end. What we are doing here basically is creating number of blocks as defined in the variables, which will come after this. Okay, and those many blocks will be attached to the instance when we create it on top of OpenStack. Okay, so let's quickly look at the variables and then we will start with the deployment. Okay, so variable files, in addition to all the information, it also defines the number of volumes and the configuration of volumes that are needed for this particular instance. So we are using the definition over here. All right. As you can see here, we have already created few Terraform variable file, which is pre-populated. Either you can pre-populate this information or you can provide this information on the fly. Okay, as you see, all the information that is needed is updated over here. These are the actual input that we need to provide by deploying using Terraform. Okay, so let's begin our initialization process. First, we need the credentials for OpenStack, and for that we need to source the RC file, right? That's where it takes its credentials for the OpenStack. The first step is to initialize the Terraform, and as you can see on your screen, it initializes the modules, the backend, and of course the provider plugin, right? Once we have the Terraform initialized, we start with the plan phase. Okay, so the next part is to create a plan, and we can use all modules or one module. And the example shows here is only a single module, which is creating an instance from an image, right? And the variable file is sent to us. But as I have described, you can provide any input at this point of time, either through a file or through each individual variable. Now let's look at what output the Terraform plan shows us. So it provides you the output of exactly the configuration that we will use for deploying the virtual machine or the instance on top of OpenStack. Okay, and as you can see here, some of the information is already pre-populated, while rest of the details will be populated once the deployment happens. And that's why you see the known after apply information over there, right? And the last step here would be to apply this plan. And the simple command is terraform apply. And we are using the same module name and the same input files, and auto approve means it is non-interactive deployment. You can make it interactive as well. Okay. To deploy a typical instance, it takes a few seconds, and the benefit is more when you try to deploy large number of infrastructure on top of OpenStack. That's where the benefit would come. So in this particular case, we are deploying a single instance, right? And it would take hardly few seconds to complete. And as you see on your screen, the output, which is the IP address allocated to that particular VM, is displayed over here. You can choose to output any other information that you desire. Let's look at the actual server that is created by using the OpenStack CLI, and it will show you the instance has been created with a provided configuration, as you can see on the screen with the specific IP address, the public IP address. And that brings us to the end of this demo, and of course the end of the webinar. So let's last couple of things about Terraform. We can quickly check the state using this Terraform show command, which basically tells you the same information that we have just described. And now you can see the information is already populated, using the different OpenStack return values. Okay. So that's it from the demo side and the webinar as well. It's time for any queries. We can take queries if you have.
Hi Sachin, Atul here.
Yes, Atul, go ahead.
So you have used Terraform to host the instances on compute node, right? On basically on OpenStack platform. But can we deploy OpenStack itself using Terraform?
Yes, we can. So when deploying OpenStack and configuring is also possible using Terraform, right? But as I mentioned in one of the slides, right, it is more of a declarative, format, right? So it is more work to define what exactly it takes to deploy the virtual machines based, or required for your OpenStack, correct? So, for example, if you want a virtual machine and you want to deploy for packages on top of that, Terraform can allow you to deploy the exact same configuration. Or the alternative is to use Ansible for deployment once you provision your VMs using Terraform. So there are multiple ways you can use Terraform, right? One is to deploy your virtual machines, correct, on any virtual platform, and then use Ansible to provision it, because Ansible provides you better control when it comes to deploy configuration, correct? Or the third option, of course, is using something like Vagrant, which can break it up. Okay, so Terraform does have that provision, but it is a bit more complex when it comes used on the declarative language, right, to deploy a complex environment like OpenStack, and then do the configuration on top of it.
Got it.
Yep.
Thanks.
Okay, so we also have a question from Saurabh. So can we manage the disk with Terraform? Yes, we do. We can. As I have shown in the demo, we can define a disk. It could be any disk. In case of the demo that we use, it was OpenStack Cinder volume, right? We can provision that disk, attach it to your volume. You can format it and even write data on top of that. Now, how do you exactly achieve it, right? So Terraform resources define the volume, right? But the provisioning after that, you need to handle that provisioning by using few set of commands. And provision, so Terraform has a provision to provide a simple shell script or Ansible script, as I mentioned, or any other type of script to provision your disk once it is attached to your virtual machine, right? So if you attach it, you format the disk using disk, then you create a file system, and eventually you create a mount, right? Mount the disk. So it allows you to manage the disk using Terraform. And since Terraform maintains the state whenever you make any changes, right? It allows you to add more disk. So if you just edit your config file and add the disk, it will provision the disk and add it on top of the view. So it provides you that option as well. So scalability is really good. Yeah. Great. Any other questions, guys? Okay, so good resources to learn Terraform. I think HashiCorp is the best way to start. But Terraform, I think we do have a lot of resources available on Google. I don't have any specific site which I can refer at the moment, but Terraform, you can easily provide information, you easily get information from Google. It's easy to learn it. I think the simple answer is Google. Any other question, team? And of course, you can always write to learning@afourtech.com. Those who are, having any queries or question, or you can reach out to me if you have any further questions related to Terraform or Vagrant or any of the topic that we discuss in this webinar so far. Okay, I think there are no more questions I see here. So thank you very much, everyone, for attending this webinar. Thanks for your valuable time. And if you have any questions, feel free to reach out to me at learning@afourtech.com or my email ID. So thank you, everyone. Have a nice day. Thank you.
Thanks.
Thanks, Sachin.